Problem 25, we're looking at the quadratic formula, but the problems are not written the way that the standard ax squared plus bx plus c equals 0, not really written in that standard form. So what we need to do is perhaps think about rearranging or missing terms. So for the first problem, we look at problem A. We have 4x squared minus 121 equals 0. We are missing a term on this one. There's only two terms. It's a binomial, but we're normally working with a trinomial. We are missing our bx term. Well, if it's not involved in the problem, that means our b value is going to be 0. So if I wrote plus 0x, 0x just equals 0, so we'd have 4x squared plus 0 minus 121, and we don't need to write the 0. That's why the problem looks like this. So our b value is going to be 0 for this. Once I know that, I can now go in, just work with the problem using 0 as my b value. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. A negative 0 is just 0, so I don't need to write that. So now I have a plus or minus. 0 squared is 0, so I don't have to write that. So now I have a negative 4 times a negative 121. That is 1,936 divided by 8. Taking the square root of 1,936, that is 44 over 8. So now I have plus or minus 44 over 8. So now I have two separate problems here. I have 44 over 8, and I have a negative 44 over 8. I can divide this fraction here by 4. That gives me an answer of 11 over 2. And I can do the same thing over here, so I get my two solutions are plus or minus 11 over 2. So x equals plus or minus 11 over 2. That's the answer to A. Problem B. This is now written in a different order. So if we think about our a, b, and c values, our a value is our number of x squareds, and I have 2 x squareds. My b value is the number of x's, and even though it's not written in the same order, I still can have that as a negative 3 x's, and my c value is still my constant term, which is now a negative 2. I could also rewrite it just in a different order. 2x squared minus 3x minus 2 equals 0. So now I'm going to use my quadratic formula. I have my a, b, and c values. So x equals, the opposite of b means it's going to be a positive 3 plus or minus the square root of negative 3 squared minus 4 times a times c, all divided by 2a. That gives me positive 3 plus or minus the square root of negative 3 squared is positive 9. Negative 4 times 2 times a negative 2 is going to be also positive. That is going to be a positive 16 divided by 4. So I now end up with 3 plus or minus the square root of 25 over 4. Taking the square root, I get 3 plus or minus 5 over 4. Separating those, I have 3 plus 5 over 4, and I have 3 minus 5 over 4. The green problem is 8 over 4, which is 2. The purple problem is negative 2 over 4, which is negative 1/2. So my solutions for problem B, x equals 2 and negative 1/2. Taking a look at problem C. There are several things I can do, but first of all, it is not equal to 0, so I need to move negative 630 to the other side by adding 630 to both sides. So I now have 15x squared minus 165x plus 630 equals 0. It is now written in this form. I could go through and solve this problem. I also, since every one of these numbers is divisible by 15, I could divide everything by 15. So if I divide this whole side by 15 and divide this whole side by 15, I get x squared minus 11x plus 42 equals 0. So 15 divided by 0 is still 0. Now, you did not have to do that step. I could have used an a value of 15, a b value of negative 165, and a c value of 630, and this problem would still work out to give you the same answers. But this is just going to allow me to use some smaller numbers. So now, if I use this, my a value now, I have 1x squared. My b value is a negative 11. And my c value is positive 42. So x equals, the opposite of negative 11 is positive 11. Plus or minus the square root of negative 11 squared minus 4 times 1 times 42, all divided by 2 times my a value. So now I have 11 plus or minus the square root. Negative 11 squared is 121. Negative 4 times 1 times 42 is a negative 168 divided by 2. Simplifying underneath the radical, I get 11 plus or minus the square root of negative 47 over 2. And here we run into a problem. Square root of negative 47. We cannot take the square root of a negative number and get a real solution. So this has no real solution. So we cannot take the square root of a negative, and that's what happened here. So problem D. Again, it's not equal to 0, so I need to go through and move by subtracting 60x from both sides. So I have 36x squared. I'm going to order it in by x squared term and then my x term, so minus 60x and plus 25 equals 0. And now I have it in the standard form. Unlike the last problem, there is no common factor that I can divide out of everything, so I just need to use these numbers. So x equals positive 60 plus or minus the square root of negative 60 squared minus 4 times 36 times 25 divided by 2 times 36. That gives me 60 plus or minus the square root of negative 60 squared is going to be a positive 3,600. Negative 4 times 36 times 25 is going to be a negative 3,600, all over 72. Now for this problem, I have 60 plus or minus the square root of 0 over 72. Square root of 0 is just 0, so that drops out of this problem. And I essentially now just have 60 divided by 72. So I do not get two solutions for this one. I only get one answer. 60 divided by 72, I can reduce that fraction. They're both divisible by 12. And I end up getting 5/6 as my solution. A positive 5/6.